Alright, hello everyone, this is Mr. Crozier. I'm going to go over problem set 3. We're going to take the antiderivative of this, and what I see here is I have x and a derivative on top. I could pull the 4 out, and then I just have the natural log of that. From this number e minus 1, that's just 2.7 minus 1, and I plug in that here into this, and I have 4 ln of e, which is 4, and I plug in 0 here, and I have 4 ln of 1 is 0, 4 minus 0 is 4. On the next one, a lot going on here, but I noticed that the derivative of sine is right there, so if I let u be sine of 2x, well then I have this derivative here, and I can do some u substitution, plug this in here. Now I'm just integrating u and go through all the steps, and I have sine squared here, and then just check it with the chain rule. If you multiply this 2 down, you have a half. Sine, derivative of sine is cosine, which is right there, and then another 2, which will get rid of that fraction right there and leave you where you started. Looking for area from 3 to 7. 1, 2, 3. 3 rectangles. The widths are 4, 3, and 2. 4, 3, and 2. And the heights are the left endpoints because they're left Riemann sums. The sum is 2.4. And then it tells you it's an increasing function, so it's going up. And if I make my rectangles from the left side, what you'll see is all the rectangles are under that curve, so it's an underestimation. The exact area must be higher than that. All right, going forward, up here, number 4. Well, I'm going to put these two together. That's 3 halves. I'm going to write it to the negative, and then I'm just going to add 1 and divide, and then simplify it back down here. On number 5, we're going to go ahead and integrate. That means we go back up. We add. Remember, if you're integrating, you're going back up, so you're adding. X, plug in 1, 1. All the x's are 1. All the y's are 1. Solve for c. There's my equation. Plug in 2. Got 32. Finding the limit. If I plug in 0, I have 0 over 0. So I take the derivative. I still have 0 over 0. Take the derivative, and now I'm here, and now when I plug in 0, I have 6 over 1, which is just 6. If you have that indeterminate form, which is 0 over 0 or infinity over infinity, use L'Hopital's rule that says you just keep taking a derivative till you get to something you can do. Graph of a velocity. So this is a velocity function. And all of this is positive, 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 going forward, going forward, going forward, stopping, now going backwards. So right here is where it switches from going positives to negatives. And again, it switches right there. Forward, reversed, forward is how you need to read a velocity graph. And if the body starts at 5 meters from the origin, where would it be at time 6? Well, I'm just going to start at 5, and I'm going to integrate this function from 0 to 6, and that's right there. And if I integrated its area, this area is 4. Trapezoid, this area is 3. This area is negative 3. So it went forward 7, back 3. It went forward 4. 5 plus 4 is 9. Going on to page 2. Page 2. We have integral, and if I use the fundamental theorem of calculus on this, I will know that if I integrate this and go from a to 1, the area is going to be 26. But I still haven't figured out what a is. But the fundamental theorem of calculator says if I do f of a, if I plug in a and I plug in 1, f of 1, and I subtract those two things, I will get 28. Plugging in 1 gives you 2. Plugging in a gives you a squared plus a. Go ahead and solve that equation. The answers are negative 6 and 5, but a has to be positive. Cross out the negative 6. What value of k will make it continuous? Well, the only area in question is right here at 2, because something happens at 2 right here. Something happens at 2, and I want them to come together, so I want them to go to the same spot. So I plug in 2 for x there. 4k, plug in 2 right there, plus 4 plus k, solve that, k has to be 4/3. When k is 4/3, they come together. Intermediate value theorem says I have a range from 1 to 2. is 0 in between there? Is there a 0 in between these right here? Well, if this one's a -1 and this one's a 15, yes, 0 must fall in there because 0 comes between there. So 0's between there. And it only works if it's differentiable and continuous. And this function is differentiable and it is continuous. Mean value theorem says that if I find the slope between 2 points, and that slope is -1, there's a point where the derivative is also -1. So take the derivative, set it equal to -1, you get 9/2. Mean value theorem again, find the slope, 1.5. There is some point where this derivative is 1.5, and that occurs at -1/2. Quotient rule, low d high minus high d low, all over low squared. A lot of simplification down to here. Extreme value theorem says that if you're looking for a max and min, it occurs at -2 or 1, or where the derivative is equal to 0. So I took the derivative, set it equal to 0. Now I have 1, 2, 3 points to check. This is the lowest, and that's the highest. Same thing here, check the points 3 and 5. When I solved this one, the other critical points were -2 and 1, or -2 and +2, but they're not in this interval, so they don't get checked, because I'm just checking this interval right here, 3 to 5. All right, on the back, zeros are when the numerator is 0. That's a -4. Holes are when they cross off. So this goes away, it's a hole. Asymptotes are things that do not go away. So we have zeros, holes, asymptotes. They're just factors. 0 on top, cross it off, a negative comes out. Horizontal asymptotes are in behavior. Cross off everything except the front powers. Those are even. 5/2 is 1/2. This asymptote is 1/2. If I cross these off, gone, 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 I'm left with still 1/2, but I have a higher x. That's going to infinity, no asymptote. Same thing here, 1/2, but I have an x at the bottom, so I have an infinity at the bottom, that's 0. Another extreme value theorem problem. I have a function, and I want to know when it's the furthest away. Well, it either happens at 0 or 2, or when the derivative is equal to 0. Derivative is equal to 0 at 1 and -1. Only that one's in there. Plug them in there. There's the output that's furthest. Same thing here. When's it lowest? From -2 to 3. Well, now both of these are in here. Both of those are points in there. However, the lowest occurred at 3, so -26. What's the particle's maximum speed? Well, speed is this function. So I want to do the same thing from 0 to 2, but what I want to do is take the derivative of this function to find my critical points. And the critical point here is just 0, which is already an endpoint. Plug them in, maximum speed on that interval. On number 19, I have a function. If I integrate it, goes back to here, plug in with c, and I'm going to plug in this point right here, and it's kind of a weird point, but the x value is e, the y value is x squared minus 2. Usually we like to have nice neat points like 3, 4, but here's my x, there's my y. Y goes there, x goes there and there. If you do the math, c is 0. Now we're just going to plug in 1, it's equal to 1. Calculator problem. Mark's driving his car along the road. He's at mile marker 12 at 6 hours. But then look what happens. He drives an extra half hour. So 12 plus from the distance from 6 to 6.5. If I integrate that velocity function, I'll find out how much extra miles that he did from position. This is a position. And if I integrate velocity, this is the extra position. 12 plus this much more, 46. Type it in on one line on your calculator. And don't forget this rule right here. If you take the derivative, here's how I remember it. if you take the derivative of e to the x, which is an exponential, it is e to the x ln of e times 1. There are 3 parts. Part 1, part 2, part 3. Here's part 1. Leave it alone. Part 2, natural log of the base, ln of 6, and chain rule. In these ones, these go away, and you're left with just e to the x. They don't go away when you have a base of 6. All right, hope this helps with your homework tonight.